For our project, we decided to look at how pH and water temperature affected populations and species type of crayfish found within the 3 rivers closest to our campus.
Within the 3 streams being explored, North River, South River, Dry River, different crayfish species will have varying populations due to differences in abiotic aquatic factors.
The first technique that we used was with the seine net. With minimal people, this made this technique very difficult. However, we managed to set up the net across multiple runs and had one person chase downstream towards the net. Once the trials were done, we concluded this technique was less rewarding overall.
The second technique we used required use of a Cerber net, which is a fine mesh net that you place at the bottom of the river, clean off the rocks, and have the water flow push everything to the back of the net. The third and final technique that we used was with handheld nets that we got from the supply of electrofishing nets. The way we used them was simply walking around trying to find the crayfish on the bottom of the streams, and we would essentially scoop them up or kick around and scare them into the nets. This was our most successful technique with the most crayfish caught in all streams using this technique.
I actually thought
Ah, fishies!
In the North River, we tested 3 20-meter long and 15-meter wide sections with differing benthic habitats where we thought crayfish would live. The water temperature stayed the same throughout, as did the pH. In this river, based on the habitat they were in, we found varying populations. However, we only caught 1 species.
Like in the North River, we tested 3 sections, each 20 meters long and 10 meters wide. Here we were most successful. The benthic habitat was the same throughout each section and populations were much higher than the other rivers. pH and water temperature remained constant throughout each section, but differed slightly from the other 2 rivers.
This one's a male. You can tell for 3 things. 1, it's got extra chelae on its tail, which are these extra fins on the side here, because they help clasp down on the females during mating season. And also it's got a skinnier abdomen than females would have, because females need larger abdomens in order to hold their brood of eggs and their young before they let them go. Also, this male has rather large claws, and that's another easy distinguishable trait between males and females. The species we have here, if you can tell by its cheeks, it's got no bumps nor any spines, meaning that it is in classification Chimbaris bartonii. That's its taxon name, species name. And these are the most common crayfish that we have caught throughout our project.
Figure 1 displays a comparison of total number of male and female crayfish of each individual species we caught among the 3 different rivers. As you can see, the y-axis is the total number of crayfish caught, while the x-axis is the names of the species we caught.
Figure 2 shows a comparison of average male to female ratios in each river we sampled. We also included pH levels on this graph to show any differences. The first y-axis is the average number of crayfish caught. The second y-axis is the pH measurement. The x-axis shows male to female ratios in each stream. Figure 3 is the same as Figure 2, but rather than showing pH readings, we showed the average water temperature per stream.
We concluded that our hypothesis was supported by our data. Water temperature differences and small pH differences between each stream allowed for differing species to be present, as each species is sensitive in its own way. Population sizes also were affected by those abiotic factors. If we were to do this again, we would test more abiotic factors in the environment as well as biotic factors. We would have a larger group of people with refined techniques.